Good morning, folks. Our next lesson on coasts. Okay, just have the PowerPoint loading up here for you. So again, we've looked at all our erosional stuff, and we've looked at how sediment is transported along the coast. Now we're going to look at our depositional landforms. Okay, so we got today's date, CC Covey connection, and our objective. Okay, so again, everything from here on out is depositional. All right, there's very little erosion happens. The erosion has already happened. Okay, we've had our headlands and our bays and our stacks and our stumps. All the material that was broken down is now been transported by our longshore drift, and it is going to be dumped somewhere else. Okay, so again, the best way to learn these is all together because it's the same processes again and again. All right, so our first little bits of notes. Okay, there's certain factors which influence how quickly this deposition occurs, just like with erosion. Okay, there's certain things that affect how quickly or how slowly erosion will happen. Deposition's the same. All right, so we do have to make a note of these three. First one is sediment size. Okay, so sediments are dropped on the coast. That's what deposition is. All right, but they're dropped when waves no longer have the energy to carry them. So obviously the heaviest and largest stuff gets dropped first. Pretty simple. Intrinsically linked to that then obviously is our wave size and energy. All right, so the smaller and weaker constructive waves, they have a strong swash. Okay, they push material up beaches or along the coast. So which move sediments up the beach and leaves it there. So these are better for deposition, these constructive waves. Whereas our stronger destructive waves usually take more sediment away from the coast. Now the next one is linked to these wave sizes. Okay, weaker, smaller waves will happen in shallower, calmer seas. Okay, like kind of what we have here in most of the Bahamas. The destructive waves occur in deeper water and areas that have a longer fetch. Okay, so deposition occurs more on sloping beaches, all right, where water is shallower, where there is shallower seas and sheltered coastlines. All right, so that's what we have there. There are three factors which affect deposition. All right, moving straight on, then we've got some keywords for today. All right, we won't finish all our depositional landforms. Well, we might actually. We might. So what we have is a berm, which is an area of the beach further from the sea, where only storm waves can reach. Okay, so it's the top area of the beach, away from where the water can reach. A salt marsh. We'll look at this in more detail shortly. Okay, an area of land which becomes filled with sediment and salt along the coast can eventually be filled in to create land. The erosion creates some stunning landscapes along the coast. Okay, depositional is no different. Okay, some of the things that are left behind are quite amazing. Okay, and also remember, deposition is when sediment is dropped. Okay, so it helps to build up and create new land. So not only do they create landforms, we can then actually build on a lot of these, and we do. Okay. Halophytic vegetation we look at in a little bit. Types of plants which can withstand salty conditions, obviously if they're going to live by the sea. And a dune crest is the top or highest point of a sand dune. Okay, so we're going to look at all of those keywords as we go through. Now, first thing is we're going to read through 4 or 5 pages of Bunnet. Okay, there's quite a lot of information, but remember it's the same types of processes again and again. So if you get a pen and a highlighter ready, we will jump straight into that. Just to make a very quick start, bottom of page 145, and again, landforms produced by wave deposition. I put in the pages for Bahamian landscapes and for New Wider World. We look at Bahamian landscapes in this lesson, but New Wider World you can have a little look over yourself. There's some decent diagrams to help you with understanding. Okay. Also, it's good to have these here for when you come back to revise, so you don't spend ages flicking through different textbooks. All right. So our first depositional landform, very simple, is our beaches, or our beaches I should say. Okay, they can be made from lots of different things. All of the beaches we know are pretty much made from sand. Shingle is small rocks. Okay, now again, you go to the south coast of the UK, there's a lot of stony beaches, and you can imagine trying to lie on a stony beach. It's painful. Okay, the material which makes up beaches comes from eroded headlands, rivers and other beaches to the action of longshore drift. Now we've already talked about that. Okay, the headlands, the stacks, the stumps, the caves, the arches, all of that land that gets eroded away, that is then carried by the sea through longshore drift and dumped somewhere else. Rivers, all rivers flow into the sea. into the ocean. Okay, and obviously as a river flows over land, it collects a lot of sediment and material, which is then dumped out into the ocean also. Okay, all of it is sorted by the action of the swash and the backwash. The strong swash pushes the coarsest, that's the biggest or heaviest material, up the beach. The backwash, where the backwash is less strong. All right, so if the backwash can't carry that away, all right, the swash will keep depositing material. If the backwash can't carry it away, if it's less strong, some of the material will get left behind. Okay, and then you get your beaches forming. So that's all it is. A beach is where there's heavy sediment dropped that can't be dragged back down by the backwash. All right, we've already looked at the keyword berm. Okay, it's the area at the top of the beach reached only by storm waves. Storm waves tend to be the largest or most powerful waves. A beach face, okay, the upper part of a beach reached by the waves, so at high tide. Surf zone, not somewhere you surf, okay, the part of the beach between the zone where waves break, all right, and where the swash gets up to. So again, we're moving down towards the sea, okay, back of beach, sea, right, and the break point, the point where waves break, all right. So again, what you'll see here, beaches are sometimes constructed between high and low tide levels. A good way of identifying this is if you ever see maybe Montague Beach, all right? There's always seaweed on Montague Beach. And when the tide is low, all right, you can see that seaweed high up on the beach. The seaweed usually marks the high water point or high tide point, all right? Because when the tide comes in highest, it pushes all that seaweed right up the beach and it stays there, all right? So again, when we are at a low tide level, all right, you got your sandy beach, you got this would be, so the berm would be back up at the top here, that would be your berm, all right, where the waves break is your break point, and so on, all right. It's shown in the bottom one down here, a little side elevation, whoops, of our beach, okay. So, ocean out here, okay, your surf zone, break point is where the waves break, it can be off the coast, berm is at the back, the beach face is the bit that we sit on, okay. Just some key terminology. Next page. Right, page 146, as you can see. Now, somebody else, whoever had this book before, used blue, okay? I would highlight the bits in, well, not this, don't worry about Barrier Beach, but I would highlight this bit in blue and this bit in blue, okay? So just keep it the same color as you would, okay? So a bayhead beach is one type, okay? This is the simplest of beaches. It results from wave refraction in bays and is usually concave in shape. So again, you can see in the diagram here, we got our headland coming out. You can see the caves and arches. And here's our bays, the curved bits. All right, so when the waves come in there, all right, they deposit the material in at the back and you get your little beach, okay? Bayhead beaches, that's all they're called. So you can draw a little arrow down to that there. So again, the headlands stick out and they cause the waves in here to be slower, okay? So deposition can then occur. We're not going to look at Barrier Beach, we're going to skip on. The first big one then that we're going to look at, the first one is called a sand spit, okay? So New Wider World, page 303, Bahamian Landscapes, page 106. That's what I've written up there. So a spit is a low, narrow ridge of pebbles or sand joined to the land, okay? Now it's only joined at one end, so at one end, with the other end reaching out into the sea, okay? It is formed by longshore drift. Now in the diagram down here we got two spits. See this thing hanging off the coast here? That is a spit, and this one down here. Only connected at one end to the land. Okay, the other end reaches out into the sea. Okay, so what we're going to do is we're going to look at how these form on the next page. Okay, so we're going to look at this bit of text here first, okay? If longshore drift operates across the mouth of a river, so where a river joins the sea, an area of slack or slow water develops, okay, between longshore drift and the river, which results in deposition. So remember, erosion occurs where you've got fast-moving, strong, powerful water. Deposition is the opposite. It happens where the water is slow, it's weak, and so on. Okay, so there's two options. The first one is if you've got longshore drift coming along the coast and then there's a river entering the sea, those two forces collide and power is reduced. Okay, when a river joins the sea, it slows down dramatically and it drops a lot of its material. All right, and this opposite flow of water also slows down our longshore drift. So deposition of material by longshore drift, right? This material builds a spit which may extend across the open expanse, all right? These can be huge, All right, there's some in the UK that are 12 kilometers, all right, long. All right, that's nearly half the length of New Providence. The tip of the spit often leads out into deep water, and the spit often turns towards the land, okay, making this kind of a hooked shape. So what I'll do is I'll show you some pictures now in a second, all right, or in the next video, and hopefully that'll explain it a little bit clearer.